solubility, what dissolves? Remember, there are two kinds of mixtures. There's a homogeneous mixture, where everything's basically the same, like juice. There's a heterogeneous mixture, where things are not the same, like sand and water, or rocks, with pebbles and sand. And these are solutions. So when you think of mixtures, there's two types. You have your heterogeneous mixture and your homogeneous mixture. Dissolve means to form a solution by mixing it with a liquid, and there are different parts of a solution. Solvent means what's doing the dissolving. It's usually a liquid. And solute is what's being dissolved, usually the solid. Water is known as a universal solvent because it has the ability to dissolve many different substances. So how do you know which is which? You, notice the underline you, add the solute into the solvent. When you make iced tea, you add the sugar into the water and then mix it. The sugar is a solute and the water is a solvent. There's usually more solvent than solute. A solution, the process by which gas, liquid, or solid is homogeneously spread within a gas, liquid, or solid without a chemical change. Formation of a solution, though, is considered a physical change. It doesn't turn into a different substance, so it's a physical change. Soluble means it will dissolve in a liquid. It normally depends on temperature. As you increase the temperature, most solid and liquid solutes become more soluble, whereas gas solutes become less soluble. Insoluble means it will not dissolve in the liquid, and it's still solid within the liquid. Later, we'll be doing concentration problems, and it's the amount of solute that is dissolved per amount of solvent. So you take the mass of the solute or the mass of solvent. Saturation is a process that occurs when no more of something can be absorbed, combined with, or added to a solution. So you have water and sugar, and then you dissolve it, and it's perfect. All the sugar has disappeared. And if you add a little bit more sugar, that sugar will not dissolve. And if you take some sugar away, well, the way I think of saturation, the solute particles equal the solvent particles. Perfect equilibrium, perfectly right in the middle.